So, starting where we left off for our notes, we have so far talked about Lewis dot diagrams and how atoms form ions by losing or gaining electrons. And now we're going to talk about how atoms come together, how those ions come together to form compounds and form bonds. And those bonds are going to be called ionic bonds. It's an ionic bond when two ions come together. So, one way that atoms can form ions is that they can lose electrons. But when an atom loses an electron, that electron has to go somewhere. It doesn't just disappear into thin air. And then remember that another way that an atom can become an ion is that it can gain electrons. And again, gaining those electrons, they have to come from somewhere. They don't just appear out of thin air. So the atom that loses electrons gives its electrons to another atom that gains electrons. So they transfer electrons. So an ionic bond is going to be a bond between a cation. Remember, a cation loses electrons and becomes positive. And an anion, remember that an anion gains electrons and becomes negative. So electrons are transferred. One atom loses and the other gains. Those electrons are moved from one atom to another and to form those ions. Another way to look at this is that it's always between a positive ion and a negative ion. And we do this, the positive and the negative, if you look at the charges, we're going to do some examples. When you look at those charges, the charges will cancel out to be zero overall. They will become neutral. And another way to look at ionic bonds is that it's always between a metal and a non-metal. Think of this as like opposites attract, right? Cation and anion, positive and negative, metal and non-metal. Okay, opposites attract. So like we said, it's between a non-metal and a metal, and they're very easy to name. First, you have to know that the metal always goes first. When you're writing the formula and when you're writing the name, the metal is always listed first. So the positive always goes first. The cation goes first. And when you name it, the metal is just its regular name. You don't change anything about the metal. So some common metals that we use are sodium, lithium, magnesium. You just name those as normal. And then the non-metal goes on the end. And there's one thing that we change about the non-metal, and that's the end of the name. We change it to IDE. So some common non-metals that we'll use in our compounds are iodine. So iodine, the ending gets changed to ide. Okay, and so the ending becomes iodide. Right? Or the whole thing with the ending becomes iodide. Oxygen, there's no really easy place to take it off, so we just take it off pretty much at the beginning. So oxide. Okay. Some of these we just it's just how it sounds best. If you can't figure out the best way to like take off the ending and change it, you just kind of how it sounds best. So oxygen becomes oxide. Phosphorus becomes phosphide. Nitrogen becomes nitride, sulfur, sulfide, chlorine, chloride. Okay, so this is when these nonmetals are in their ion form, is when they get the IDE ending. So chlorine, I had some people ask me in the beginning of the year, they didn't realize that chlorine and chloride were the same thing. And they are talking about the same element, but they're different in the way that chlorine is talking about a neutral atom and chloride is talking about a chlorine ion. So that's the difference here. Okay, so our first example is going to be when we combine sodium and chlorine. So combine a metal and a nonmetal, so they both have full outer shells. The metal is going to give electrons to the nonmetal. So when we draw this out, we're going to draw a sodium and a chlorine. Sodium is in group 1, so it has 1 valence electron. Chlorine is in group 17. It has 7 valence electrons, so there's 7 drawn there. So notice, remember that metals want to give away their electrons because they've got less than 4. So this lone electron that sodium has is going to be gone. It wants to get rid of it. And notice that chlorine has one empty space next to this electron. It's got an empty space here. And so this electron from sodium is going to fill the empty space on chlorine. All right. And so this will become positive, this will become negative, and they will form NaCl. You just put the two symbols together, NaCl. So let's look at the charges for the two ions that we just drew when they came together to form the compound. Sodium had one valence electron, so it has a charge of +1 because it loses one electron. Chlorine, it needs one electron, it has 7. It needs one more to have 8 to be full, so it's going to be a -1. Remember, electrons are negative. You lose electrons, you're positive. You gain electrons, you're negative. So add those charges together, +1 and -1. When what do you get? You should get 0. +1 and -1, when you combine those, they cancel out to get 0. And so that makes the overall compound neutral. So yes, you have a sodium ion and a chlorine ion. So sodium and chloride, when they combine, one's positive and one is negative, but the overall compound is neutral. It does not have a charge. And then the name would be Na is sodium and Cl is chlorine, but we need to change the ending to IDE. So overall it's sodium chloride. Okay. Example number 2. What happens when the charges don't cancel? Look at the ionic bond between magnesium and bromine. So magnesium is +2, it's in group 2, and bromine is -1, it's a halogen, group 17, 1 away from noble gas, it's a -1. +2 and -1, these do not cancel. These do not cancel. So what can we do? Well, if we draw out the Lewis dot, we can see here that magnesium has 2, and each of the bromines here, they each have 7. Okay, magnesium wants to get rid of its electrons. Let's do a brighter color here. Get rid of its electrons. So it gets rid of one there, but then it has this one left over that it needs to get rid of. And so what we need to do is we need to add another bromine. So when we add another bromine, we're adding another space for that electron to go, and it's going to go right there. So that way magnesium can get rid of both of its electrons and form its +2 charge, and then each of these bromines forms a -1 charge. And if you add up all of those charges, then you would get 0. So +2 and -1 give you 0. So what can we do? We can add another bromine. And now the charges will cancel like we said. We have a +2 from the magnesium, a -1 and a -1 from both of the bromines, and that will give you a charge of 0. Okay, and then the formula. So we had one magnesium, and then we had a bromine and a bromine. So for the formula, the metal always goes first, so magnesium first, and then there are 2 bromines, so the 2 goes after the Br. So magnesium bromide is the name. So MgBr2, and the name is magnesium bromide. Our third example is lithium oxide. We have lithium and oxygen. So lithium is in group 1, so it has 1 valence electron. Oxygen is in group 16, so it has 6 valence electrons. Let's do purple. So we've got our 1, 2, 3, 6. Okay, there's 6 of them there. All right, so lithium can only get rid of 1 electron. Okay, but that leaves this empty space here Remember, oxygen also wants to be full, so not only does lithium want to lose all of its electrons, but oxygen wants to fill that shell. And remember, oxygen needs 2 electrons to do that. Lithium can only give away 1 at a time, so we needed to add another lithium here to fill this other empty space for oxygen. Okay, so lithium forms a +1 charge when it loses 1 electron. Oxygen wants to gain 2 electrons, so that's a -2. Okay, and when we combine that, then we have our +1 + 1 -2. That gives us 0. Okay, and then the formula is going to be, there's 2 lithiums, and remember the metal has to go first. Lithium is a metal because it's in group 1. So lithium goes first, so there's 2 of them. So the 2 goes after Li, and then the O for oxygen. So Li2O, and it's lithium oxide. Number 4. Now this one gets a little complicated. Let me add in another, just an extra page here so I can draw this one out and show you the steps. There we go. Yes. All right, so calcium and phosphorus. We're going to draw this one out together. So calcium is in group 2, so it has 2 valence electrons. All right, I'm going to switch colors. Phosphorus is in group 15, so it has 5 valence electrons. All right, so calcium needs to get rid of the 2 valence electrons it has. Okay, and phosphorus, look at phosphorus. It has 1 lonely electron, 1 lonely electron, and 1 lonely electron. So it needs 3 electrons. It needs 1 here, here, and here. Okay, so phosphorus needs 3 electrons, but calcium only has 2 electrons to give away. So be careful in this one, it gets a little complicated. So this electron can fill that space, and this electron can fill that space. Now that calcium is good, but phosphorus is not. So what we can do is we can add another calcium. So calcium comes with 2 electrons. Okay, so this electron can go here, and now our phosphorus is happy, but our new calcium that we drew is not. So we have to go back and forth just a little bit, and it gets a little bit complicated, but you won't have to do very many of these, I promise. So another phosphorus, because remember, when we form these bonds, both of our elements have to be happy. We will come to a point where we don't need to add anymore eventually. Okay, so now this electron can come down here. Okay, now that calcium is good, but my phosphorus again, not happy, so we need another calcium. Okay, so here and there. Okay, and now we're finally happy. So we are filling in these spaces here on our phosphorus. So I'm going to zoom in on this. So imagine an empty space where these electrons should be. Okay, and so what we're doing is we're filling in those empty spaces where the electrons should be. All right, writing the formula, the metal needs to go first, so that's calcium. How many calciums do we have? Count them up. We have not the electrons, but how many calcium atoms. So 1, 2, 3. We have 3 calcium atoms. So we're going to put a 3 after Ca. And then phosphorus, and how many of those? There are 2 phosphorus ions. So we're going to put P2. So that's my formula, Ca3P2. And then the name is calcium phosphide. That's the name. So each of these calciums is +2 because they each lost 2 electrons. So if we add up all my positives, 2, 4, 6, so it's going to be +6, okay? And each of these phosphorus ions is going to gain 3 electrons, so they're each -3. Now if I have 2 -3s, overall that's -6. And the charge, when we add those up, they cancel and give us 0. I have 6 positives and 6 negatives. Okay? So let's scroll back up to our slide and see how we did. All right. So that looks pretty good. Everything's matching there. All right. So that's how you draw these out. All right, you're drawing the Lewis dot diagrams, and you're giving away the electrons on the metals, and you're giving them to the element on that is the nonmetal, and the electrons are filling the empty spaces on the diagram. Okay. There is an easier way. If you're not as visual, if you can do a little bit more math in your head. The way that we can do it here is if we write out the symbols, we write the charges, and then we need to think about how many of each element you will need in order for the charges to cancel out or equal 0. So for this one, sodium is in group 1, so it's +1 on the charge. Sulfur is group 16. It needs 2 more to get to a noble gas. It's -2. It's going to gain 2 electrons. Now, when we're thinking about this, okay, for the charges to cancel, +1 does not cancel with -2, right? I need another positive to cancel with the -2, so I need to multiply that by a 2. If I multiply that by a 2, then it will cancel with my negative. And so when I write the formula, it's going to be Na2 S. Na2S. Okay? Because if I have 2 positives, that will cancel out the -2 from the sulfur. So Na2S. And then the name would be sodium sulfide. Sulfur turns into sulfide when it's an ion. Okay? So our next example is calcium and fluorine. So again, write out the symbols and the charges. So Ca is in group 2, so it's a +2. Fluorine is a group 17, a halogen, so its charge is -1. Okay. +2 and -1 do not cancel. And so we need more negatives to cancel out the +2. So we need to multiply fluorine by 2 so that will be a +2 and a -2. So we need 2 fluorines. So that's going to be CaF2, and make sure the 2 goes after the F and not the Ca. We only need 1 calcium because calcium is +2. Fluorine's only -1, so we need 2 fluorines. Okay, if I have another fluorine, then -1 will cancel out the +2. So CaF2, and the name is going to be calcium. That part just stays the same, and the ending fluorine becomes fluoride on the ending. Okay, we got 2 more examples. Our next example is magnesium and oxygen. So magnesium is group 2. It is +2. Oxygen is a group 16, so it's a -2. If you don't have these charges written on your periodic table, guys, I don't know what to tell you. You're just going to have to memorize them. Or how about this? Write them down on your periodic table right this second. You need to know the groups and the charges. You just have to. So, do +2 and -2 cancel? Do they give us 0? They do. They do give us 0. So we do not need to add any extra multiplication here or anything like that. No subscript. So this is just going to be MgO. No numbers. Just MgO. Because the charges cancel. So this is going to be magnesium. And then the oxygen turns into oxide. Magnesium oxide is just MgO. Okay, and our last example is going to be calcium and nitrogen. Calcium and nitrogen. So calcium is in group 2. It is +2. Nitrogen is group 15, so it is -3. +2 and -3 do not cancel to give 0. But if we multiply both of these to get to 6, then they will cancel. Okay, you have to go to the greatest common factor. Or greatest common factor or least common factor? Greatest common factor for math, okay? So if I multiplied this one by a 3, that will give me +6. If I multiply this one by a 2, that'll give me a -6. And +6 and -6 do cancel. So when I write the formula, I'm going to need 3 calciums because we multiplied it by 3 and 2 nitrogens because we multiplied it by 2. So it's going to be Ca3N2 for the formula. Okay, and if I have 3 calciums, that's 2, 4, 6. Okay, and if I have 2 nitrogens, that's -3, -6. Adding that all up, +6 and -6 gives us 0. And the name is going to be calcium nitride. Calcium for the metal, nitrogen turns into nitride.